Before we can explore the nth derivative in example number 3 of the higher order derivative unit, we need to understand factorial notation. I've written a small description over here which says that it is factors decreasing by 1 each time until you get to the factor 1. And when I write it in factorial notation, instead of writing all the factors out, I can write it simply as one term. So let me give you an example. Let's say we had 5 factorial. What does that actually mean? Well, it means that I start with the factor 5 and then I times it by consecutive factors decreasing by 1 each time. So I must times that by 4, then decreasing by 1 again, by 3, and continuing like this until I get to the factor 1. You can see that these factors are positive factors. So for example, if I said to you, what is minus 3 factorial? There is no solution. So the number cannot be a negative number. Interesting as well is 0 factorial is in fact 1, and that can be explored separately. Let's see though what it would have been if I had started with an x. If I had said that the first factor was x, and then I times it by consecutive smaller factors, the factor 1 smaller than x must be x minus 1. And then if I times that by 1 smaller than that, that would be x minus 2. And so I would continue until I times by 3, by 2, and my smallest factor is always 1. So if I wanted to write this in factorial notation, this would in fact have been x factorial. The factorial sign is the exclamation mark sign on your calculator. Now that we know a bit about factorial notation, we're ready to investigate the nth derivative of f of x. Now with any investigation, if I want to find the nth derivative, I cannot start there because that's the most difficult derivative of all. I must start right at the beginning, and so the first derivative is the first one that I need to find. So if I had f of x and I want to find f prime of x, I must find the derivative of the composite function. The outer function is x to the minus 1, and the inner function is 2x plus 1. Finding the derivative of the outer function, I find that it is going to be minus 1 all times by 2x plus 1 to the minus 2. And now I must still times that by the derivative of the inner function, which is 2. Now I'm going to find the second derivative, which is going to be the derivative of the first derivative. Now you'll notice that I do not bother to simplify, and that is a trick that you need to remember if you want to find the nth derivative. Don't simplify anything because all the clues are in the factors as they are written out. So now if I want to find the second derivative, then that must be the derivative of this composite function, 2x plus 1 to the minus 2. I already had a coefficient of minus 1, so minus 2 becomes a coefficient factor. Then I times that by 2x plus 1 to the minus 2 minus 1, which is minus 3. And then I must still times that by 2. Lastly, I must also times that by the 2 that I had before. Going on like this and finding the third derivative, I'm going to find the derivative of the second derivative. Now remember, the part that I concentrate on every time is the part that has got the variable. As I've got quite a lot of factors now, it becomes awkward to see what I'm doing. So I'm going to highlight for you the part that I'm finding the derivative of. It's the part I've highlighted in yellow. So all the other numbers are just factors. As they're constant factors, they don't make any difference to what I'm doing with my derivative. So let's now find the derivative of the second derivative. That means it's going to be minus 3, and then the bracket, 2x plus 1 to the minus 4, and then the derivative of the inner function is once again 2. Maybe you can see a pattern starting to form over here, but just so that we're absolutely sure what we're doing, we're going to find the fourth derivative as well. Once again, I'm going to highlight the part that has the variable so that we know which part we're finding the derivative of. All the other parts actually are just a coefficient. So here we go. All the coefficients that I had before I'm going to write down, but I'm not going to write down them in a simplified form. Now finding the derivative of that composite function, it's going to be minus 4 all times by 2x plus 1 to the minus 5. Remember, I had a 2 times by a 2 times by a 2 already, so I need to times that by a fourth 2. I think I'm almost ready now to find my nth derivative. In order to find my nth derivative, I'm going to see what trend came out. Now, the first thing that I notice is that I had 1 minus when I had the first derivative. I had 2 minuses for the second derivative, 3 minuses for the third derivative, and 4 minuses for the fourth derivative. So if I want the nth derivative, I must clearly have n minuses. Now if I take the minuses out and I represent them as a minus 1 on their own, I'm now just left with the factors of 1, or 1 times 2, or 1 times 2 times 3, or 1 times 2 times 3 times 4. Do you remember what I said to you? If I have got, for example, in the fourth derivative, 1 times 2 times 3 times 4, that's the same as 4 times 3 times 2 times 1, which is 4 factorial. Well, in the nth derivative, I must then have n factorial. Now moving on and taking a look at my bracket. In my first derivative, my bracket was to the minus 2. In my second derivative, the bracket was to the minus 3. Then in the third derivative, to the minus 4. In the fourth derivative, it was to the minus 5. Now you'll notice every single time I say to you, take a look at the derivative that you had, the first, or the second, or the third, or the fourth, and try and find a link between that number and the number that you've got for the bracket. Now, if I took my first derivative, number 1, and I made that a minus number, and then I minused another one, I've got minus 2. Let's see if I've got a trend that is going to work for the nth derivative. So if I take my second derivative and I make it a minus number, so it's now minus 2, and then I minus another 1, I've got minus 3. For my third derivative, if I made that 3 a minus 3, and then I minused another 1, I've got minus 4. So by now you can see if I take my derivative number, in other words this time it's n, and I made it a minus number, and then minused another 1, I'm going to know how many of that bracket factor I will have. I'm almost there. The last thing I need to do is I need to find out how many 2's I've got. When I had my first derivative, I had 1 2. When I had my second derivative, I had 2 2's. For my third derivative, I had 3 2's. And then for my fourth derivative, I had 4 2 factors. So it stands to reason, for my nth derivative, I'm going to have n 2 factors. What I've done here is I've given an expression for finding any derivative of this function f of x.